Hello everyone, welcome to lesson 2-4 where we will dive into NumPy array basics. So before we dive into the lesson, here are the learning outcomes. The first one is where you will be able to understand the difference between Python lists and NumPy arrays. And the next, you will be able to learn how to construct multidimensional arrays. And finally, you will learn how to modify and manipulate arrays efficiently. So let's get started. Well, a NumPy array allows us to store multiple values in a single object. For instance, we can store like 1,000 floating point numbers in a single array variable instead of using multiple variables, like what we've learned before. And then Python lists are mutable, so you need to understand the meaning of mutable. It means that we can modify, add, or remove the items after the creation. However, NumPy arrays provide better performance and efficiency. So now let us create a simple Python list containing of 5 students' marks. So I have 5 student marks, 26, 30, 90, 54, and 40. Those are the student marks. And then we first initialize an empty list, and then we use the append function to add floating point values to it. When I say floating point values, it means that these numbers, 26, 30, and so on. So this method works, but as we will see later, NumPy arrays are more efficient for numerical operations. But I have to introduce you to the basics, which is the Python list first. So let's dive into the details of the coding. So each number is appended to the list by using the append function. So you have to remember this, okay? So a list in Python can store different types of data, including integers, floating point numbers like these, the strings, and the Boolean values. So for instance, you can also append different data types in a single marks variable. So here, of course, the marks are the floating point numbers. So that's why in this particular example, I have listed all floating point numbers. But actually, you can append the different types, like strings or Boolean values. So now I want to share with you the code for creating a list of 5 student marks using a NumPy array instead of using the Python list, based on what we've discussed before. Before using the NumPy arrays, we must first import the NumPy library over here. So again, I've used this the abbreviation or simple name NP for NumPy, which is common. So this library provides efficient numerical operations, making data manipulation much faster compared to regular Python lists that we have discussed previously. Well, a NumPy array is defined using square brackets and elements separated by commas. But unlike lists, NumPy arrays require elements of the same data type. So you cannot use like floating points here for the first element and the second one as the strings. No. So a NumPy array require elements of the same data type, making operation faster and more efficient. Well, of course, we can convert an existing Python list into a NumPy array by using this particular built-in function, which is the array function. So this particular approach is useful when we want to transition from the standard list to a more efficient NumPy arrays. NumPy arrays use zero-based indexing. What does it mean by this? It means that the first element is at position 0. Over here, for example, here we have the first element as 26, and then the second one as 30. So the indexing begins with 0, and then 1, 2, 3, and so on. So we access an element by using the square brackets like so, with the index number inside. So for instance, here I have used the number 2, and then I am actually accessing this value. So in the console, 90 will appear. Well, we can also initialize an array with zeros using list comprehension inside the array function. So this is the Python comprehension to create 5 zeros. So this is very useful when we want to prepare empty arrays for later calculations. But there is a shortcut for this. So you have a challenge to try to find a shortcut by still using the NumPy library. But there is a shortcut for this. In this particular example, the variable I is the dummy variable that iterates through a range of 5 values, right? So remember that we've learned before, the range function will generate a specified numbers So a list of numbers. So here, for example, I am using 5, so it will generate 5 numbers from 0, 1, 2, 3, 4, like so. Well, this method ensures all elements are initialized to 0 because I have used 0 over here, and then before we modify them later. We can also generate a sequence of numbers using the list comprehension inside the array function. This is the array function. Previously, I was a dummy variable, but this time we use I to generate the numbers. So here, each element is twice its index value. So I as the index value. So, we use the range function that will generate 0, 1, 2, 3, and 4. So each element will be multiplied by 2, for example, in here. So basically resulting in a sequence of 0, 2, 4, 6, and 8. NumPy arrays allows us to modify elements directly by using their index. So in this particular example, we change the second element to 100. So this is the first element. The second element, which is indexed by using the value, the integer 1. So we try to access the value at position 1, and then we assign it to a value of 100. And of course, NumPy is very flexible and it supports multidimensional arrays. So here we create a two-dimensional array of shape 5 by 2. So 5 rows by 2 columns, which initialize with zeros. So this is how we do it. So this is useful when working with matrix-based data, because later on you will be learning about matrix, and then you might want to create a zero matrix. So in this example, M represents the number of rows. Here we have 1, 2, 3, 4, 5 rows, and then N represents the number of columns. And so in this case, we're using 2 columns, so N is equal to 2. So the thing is, NumPy allows us to easily create and manipulate multidimensional arrays. You will see later how. Now, if we want to access an element in a two-dimensional array, we have to specify both the row and column indices. So for instance, here, I want to modify the value of the cell, this one. So I have to specify the row and the column indices. So the row index is 2, the column index is 1. So for example, here it retrieves the value at row index 2 and column index 1. So it will be 0, 1, 2, 2 for the row index, and 0, 1. So 1 is the column index. So it will access this cell, and then it will assign a value of 50 to the cell. So you can always change the value here up to your preference. So to summarize, a list can store mixed data types, while NumPy arrays store a single data type. So I have an example here. For instance, you can always append a floating number, and then next you can append a string, and so on. You can have a mixed data types in a single list. But for NumPy arrays, you cannot do that. So it stores a single data type. And of course, NumPy arrays are faster due to optimized memory usage and operation. So I really suggest you to use NumPy arrays whenever you want to have a quick computation later on. And next, NumPy supports vectorized operation for efficient calculations. For example, here I have a few operations here. So let's say if I have marks as my NumPy array, and then I plus 5, so meaning to say it will do an element-wise operation. So where each element will be added with 5. So in the next example, if you apply the cosine function from the NumPy library, and then it will also do an element-wise operation where it will calculate the cosine of each element. And then finally, I have another example where I've multiplied 2 NumPy arrays together. So I have the first array and the second NumPy array, and then the result will be the multiplication, the elements-wise multiplication, which is something like this. And then finally, NumPy array natively supports 2D and 3D arrays. So in the previous example, they were only up to 2-dimensional case, but actually you can go further, 3-dimension, 4-dimension, which is which are tensors that we will look into that after this. So congratulations, we've reached the end of this lesson. So I'll see you in the next video. Bye bye.